Sound and data.
So we had this great opportunity to meet up with Garth Paine online, talking about all the great projects he's working on, specifically the Acoustic Ecology Lab. But Garth, why don't you go ahead and introduce yourself?
Sure, Scott. Thanks for the invitation to chat. I think of myself as a musician and a composer, and I have lots of interests around that. So one of them is obviously composing music both for others and for myself to perform. But also I've always done a lot of field recording, and I like to go out at 4 a.m. or something and set up out in the wilderness, and start recording and just lie down on the ground and listen for a couple of hours uninterrupted. And I find that really fascinating, how much detail there is in the sound of the world, but also how that varies over time, from season to season, and increasingly varies with impact of climate change. And so I tend to bring those kind of three areas: acoustic ecology, field recording, and composing and performing, often with interactive systems, together. And I like to think about my practice as being focused on sound as material, which allows me to think about all those things as kind of being equivalent, rather than, here's the composer and here's the acoustic ecologist and so on and so forth. And, I think increasingly that we just don't listen enough. And, we as you're pointing out, we can be really quick to subject the sound stream to analysis and to, turn it into a bunch of numbers that we can map onto something and use for whatever purpose. But actually just listening tells you so much. And it makes me think about the fact that I used to make a lot of interactive dance works, and quite a lot of them with biosensors on the dancers. And I would record all the data which came in as OSC stream.
We were talking about sound as material compared to sound as data. I think that started. I'm really becoming concerned because I'm getting all locked into this thing, since I'm sort of identified myself as so involved in sonification. Sonification has data in the definition of it. And so if you step outside of that at all, or the representations you're making, like resynthesizing data into sounds, then listening to those sounds, you're still on some level listening just to data and not to the world, if you know what I mean.
Yeah, I mean, it's true. I think we don't just listen enough.
Right.
But I also think increasingly, as I continue to make field recordings, for instance, in Joshua Tree National Park, and we've been making field recordings there for 6 or 7 years now, and
Cool.
And then we trained members of the public through listening workshops and field recording workshops. So we have a bunch of people who actually make recordings at the same location.
Oh, wait, can I just want to back up, because part of my thing, in terms of the sonification thing, is this idea of training people to be familiar with whatever the sonification thing is. Right. So this process of training, what is that like? I wanted to catch a little bit of that.
Yeah, so I guess, so we do a lot of listening workshops, which we run in preserves and national parks, kind of across the southwest, and these are with members of the general public, mostly, and basically we spend about half a day teaching 3 listening modes, which is passive listening, directed listening, and active listening. Just to quickly summarize those, passive listening would be just trying to listen to the entire soundscape as a singularity, just hearing the entire thing at once, which sounds really simple, but it's actually really difficult to do because our kind of biology teaches us to listen out for change, and particularly to listen out for things that might be threatening to our lives or security.
Yeah, exactly.
And so not allowing your mind to tune in on these things can be quite difficult. And then directed listening is really directing your attention to a single sound, a bird call, for instance, and then really trying to put your listening out with that source, that bird, and trying to really, like a microscope, focus in on finer and finer detail of that sound. And then active listening is really about listening to the relationships of the sounds in the space. So, this bird call responding to that bird call, causing reverberation of, that building, etc., etc. And so that kind of sets of active relationships between the built structures, the natural structures, the human-made sounds, etc. And so that's active listening, which really it gets you close to thinking about and listening to the acoustic ecology of it.
So I'm curious how you derived those three, because there's the famous articulation by Pierre Schaeffer, which is kind of, I think he had four though, and I forget what the fourth one was.
Yeah, me too.
Not listening, maybe.
Right. And he used slightly different terminology.
Yeah,
and there's
certainly,
also the Michel Chion's treatise on listening and so on. So I find those three easy for people to grasp the notion of when they're put that way, and distinct enough for them to understand them as different skills. And what's really happening in a listening workshop is that we're helping people understand this idea of modes of listening, and then really it kind of gives them names to put on skills that they already have, and through the fact that they can label them, it allows them to direct their attention to a particular mode of listening, and then to have a listening practice that they can go and practice and engage with directly. Now, that's not to say that they didn't have those skills beforehand. We all have those skills, but we don't kind of formalize them, and then we don't practice them generally.
Right.
So I find, and often people tell us at the end of workshops, oh my God, the whole world is different, and so on. You transform my whole perception of the world, kind of thing.
That's cool.
It's really cool, but I also find it really interesting because what it does for me is it just affirms the incredible power of listening. And what they're really telling me, which, coming back to your point about data, is that they now perceive and understand the world around them as probably more complex, richer, more interdependent.
And back to your thing about just listening,
and these
listening,
exactly. And these things all come just from listening to the sound of the world.
Right.
So I actually think of the sound as a really rich data source, because it's unique to every environment, and it's and you can go through these kind of sonic niches that are specific to different species, different environmental conditions, and so on.
Right.
And it changes dramatically when the air is cold. The molecules are closer together. The sound travels further.
Or the sound in fog. There's that really distinct and hard to describe quality of the world during a foggy day, sonically.
Right.
Yeah.
Right. Exactly.
Hey, so did you? I know her history well enough to think I remember that you weren't associated with Pauline Oliveros and her deep listening practice, which is in the same realm, and she taught a lot of the same sort of conceptual models when she did her workshops. Did you have any influence from her?
Yes, absolutely.
Oh, you did. Oh, I'm sorry, I didn't know
Yeah, I
that.
knew Pauline. I haven't done the certificate, but
Yeah, yeah.
yeah, she's a friend.
Right, me too.
Her work, of course, is fantastic and continues to have
No
a tremendous.
kidding. Yeah, I just sent on the sonic meditations to a friend of mine who's a theater producer who wanted to get into sound-related meditation, and I said, "Well, you got to read these," you know. I said,
Yeah,
"Well,
cool.
the whole book, you know." Yeah.
Yeah, fantastic.
Yeah.
No, absolutely. I mean, a profound impact that Pauline had.
Yes.
Um, and I guess,
I mean, I worked with her quite a bit during a certain period, and you and I never crossed paths then.
yeah,
It came later, I guess. Yeah.
yeah,
Yeah.
yeah, no, I mean, so I guess what we've been trying to do is to package, well, package isn't a horrible word, but
Yeah. Right.
to put together listening workshops and experiences that are really directed towards engaging with the natural environment in particularly in national parks and state parks and so on, national monuments, and that's been by and large around the idea that lots of people in those areas are very concerned about climate impact. But they feel that there's not a lot they can do because they're not in the big cities. They can't go protest and so on so easily.
Right.
And they feel kind of detached from the whole thing. So listening workshops was a way of helping people re-engage with the environment that's around them, and give them a framework of observation, if you like. And then training people to make field recordings for us every month helps build a sense of stewardship and agency about that.
Well, you have a huge archive, right? As I remember.
Right.
Yeah.
Right, and it's growing much faster than we can actually get it online, because we have a database online at ecolisten.org. I think it is .org or .com, and so. Yeah, ecolisten.org. And so you can actually go there to the Listen database and, select sites, and then the recordings are all listened to and tagged.
And time tagged too, right? Yeah.
Right. And tagged for like bird calls or plane or car or whatever.
Uh-huh.
And
now that
coyote.
Just because of my other research, yeah, and I think I remember talking to you about this when we had another conversation. But you're not using like machine listening. This is tagged by human listeners that listen to all these archival recordings, right?
Right. That's lots of dedicated students who listen to this stuff and tag it for us. Yeah.
Wow, amazing.
No, right. We're in the process of building a kind of public volunteer base to do that.
Oh, like
tagging.
citizen science kind of thing.
Right, exactly.
Cool.
We have some people who've just started that for us. And then we also, we are working on automatic tagging approaches because we have a project called Ecosonics that has been looking at the psychoacoustic properties of environmental sound and modelling that with weather data. And
wait, let's parse that a little bit. What do you mean? Psychoacoustic quality of this sort of subconscious sound of an environment you're in? Is that
right? So every environment has its own kind of signature, right? But depending on the foliage that's there or the amount of rock for reverberation, the temperature, the species that live there, etc.
Right.
And all of those things combine to create a sonic signature for that environment.
Yeah, Murray Schafer had those like acoustic maps that were kind of like
right.
The first time I thought about the world that way. I guess, yeah.
Yeah, and so so then if you think about that, then that soundscape also changes from season to season, because different animals come in and out of that environment based on season.
Right.
But also it changes. If the temperature is hot, the molecules of the air are further apart. Higher frequencies don't travel so far as when they're cold, and so on and so forth. And
wow,
so
that's really true, and something I hadn't thought about in terms of my nature listening. So that's really a cool little tip. Yeah.
Yeah, because a lot of people, when I'm talking to them about this, especially if they go skiing, and they'll say, "Oh yeah, like when you go up the mountain and you get out and there's snow all around you, and you close the car door, there's this really dull thud, and it feels like all the sound just gets sucked away from you."
Yeah, right.
And it's because of all that snow just absorbing all the sound.
Right. Yeah, it's amazing.
And then the quality of the sound being like really crystal clear because of how cold the air is, basically.
Yeah, the two combined. I mean, the sort of diffraction that the snow on the ground creates, plus the cold air itself, which would mean, let's see, that it would be denser, and therefore the sound would move faster, actually. So higher frequencies, yeah, all that, yeah.
Right.
Wow, that's cool.
And so I looked at what research was out there in terms of, measuring psychoacoustic properties of environments, knowing, for instance, that we would avoid environments that have like a harsh signature or a particularly loud or whatever. We wouldn't hang out in those places.
Like a bar? Is that what you're... No.
Well, you might think of a downtown park
near the tracks, whatever, yeah.
Concrete and stuff, Yeah. And so everything, all the traffic and the trains going past sound really harsh and bright, and and it's loud, and it's kind of like, I don't want to hang around here. So what we did is we started using Mel frequency cepstral coefficients, MFCCs, to analyze this big database that we've got every 200 milliseconds, and then to pull the weather data from a local weather station near the recording site at the same time, and essentially to use machine learning to build a model of the psychoacoustic parameters mapped onto the weather data of the time.
To see if there's like a well, not a Fletcher-Munson curve, but like a spectral window that changes with the high pressure system and that kind of stuff.
Right, and so the MFCCs kind of give you this sense of being able to determine how many distinct signals there are in any snapshot of audio, which we then refer to as our acoustic diversity measure. And this is kind of slowly looping back to your question about tagging events.
Right.
So that we're starting to be able to use machine learning to detect the diversity of signals, and then to start looking for events in that signal.
So are you differentiating, like, there could be a bird call, but also like a plane flying over, and then they might share some of the same frequency band, right?
Right.
So that would be a problem for something that's not like human perception, but machine perception.
Right. And so MFCCs are quite good. They're used a lot in hearing sciences to look at, how many distinct signals there are in any snapshot. And so it's a kind of different approach to if we were using like a spectral mask, for instance, to look for a bird call or whatever.
Yeah.
Then we would have a lot of confusion between those frequency ranges. But in MFCCs, if we can look at what the diversity is, then we can try to isolate each of those signals, which is not going to be the whole signal, and see whether it's enough to learn that's a car, that's a coyote, that's a mockingbird, that's a crow, that's a quail, whatever.
That's some rocks or whatever being, wow.
Tall rocks, we have those in the desert.
Yep. They don't fall that often, but
right.
but when they do, It's a
when they
thing.
do, watch out. Right. So
Wow.
so we've been working on that, but the more interesting aspect of that, coming back to the kind of data question,
Yes.
is that this model showed us that there was actually extremely strong positive correlation between our acoustic diversity measure and cloud cover, wind speed, and temperature. Like
That's interesting.
like
Wow.
really strong, to like 7 decimal points strong. And then a really strong, equally strong inverse relationship between acoustic diversity and dew point and visibility.
Okay, so the part that like I went like, what? Wait, was the psychoacoustic part of your initial exposition of this idea.
Right.
And it seems to me that this would be psychoacoustic, but so sort of subliminal and unconscious, right? Our awareness
Yeah.
of things changing. So that's really an interesting aspect of it, to me anyway.
Yeah, because it seems it's true, but the thing is that the reason I started thinking about this is from all of the time that I've spent out there making field recordings, lying on the ground.
Right.
You can feel this stuff, like you can feel the density of the air on the skin. You can hear
Yeah, certainly.
how the sound changes, with different qualities.
Well, I mentioned
of the
fog.
weather.
I mean, I'm quite fond of
Right.
the sound in fog. Yeah, right.
Right. Yeah. So that would be related to dew point, right?
Right.
And so there's actually a very strong statistical relationship between the acoustic diversity measure, and dew point.
So humidity
yeah,
too would have the same
right,
kind of quality.
that up
Yeah.
intuitively,
Yeah.
right?
Right.
And so the point of this was to try to think about would changes in weather patterns over time change the psychoacoustic properties of an environment such that species might leave that environment.
Well, yeah, that's what was just occurring to me. I mean, we're saying psychoacoustic, but it could be the psychoacoustics of squirrels or whatever. I mean,
Exactly.
yeah.
Exactly. So making an assumption, of course, that animals also hear, psychoacoustically.
Right. Well, yeah. Well, that's a. We definitely do map a lot onto everybody.
Yeah. Yeah. So I have not found any research around that question.
Hey, if you need to take that, go ahead. I mean, I can.
Oh, it's not my call, actually. I don't know where that music's coming from.
Really?
Yeah. It's not me, man.
Well, that's weird.
Sounds like you're on hold.
Yeah.
It's Skype trying to sell us something. Here we go.
Yeah. Wow. That is weird. Here, what am I gonna do? This is my system audio.
Yeah, that sounds louder.
Oh.
There you go. Did you get it?
It stopped. I don't know what it was.
Yeah, they gave up. They're not selling you dynamite.
Yeah. Well, there's a bunch of alarming stuff about psychoacoustics in general. I mean, one of the things that was occurring to me while you were talking about that, I did bring up bar, like a place you don't want to be.
Yeah.
Because a lot of times I don't want to be in a bar. I can't even.
Right.
I have to scream at the person I'm talking to, and there's some fucking music going that I can't.
Right.
And I don't understand this thing that's happened with humanity relative to music itself, in that before, let's say, Edison, although he gets too much credit, but before recorded music, the only time you heard music was when there was musicians in the room playing music, And now you can't go somewhere and not hear, and especially bad music a lot of the time.
Right.
I mean, it's like, God, it's a horrifying, talk about acoustic. I mean, because what's cool about the whole, for me, I mean, when I first was talking to you at ZKM and our conversations afterwards and stuff about acoustic ecology is I'm concerned about this urban acoustic ecology as well. I mean, it's like that's a real thing. I mean, I totally appreciate the sort of more biological aspects of your core work, but anyway, I just thought I'd throw that in there.
I think these methods that we're developing can equally be applied in the urban context, and should be. I mean, I kind of look forward to doing that. The thing that started me thinking about this was that I hear differences. Like I was saying, we've been recording for quite a few years now in Joshua Tree, and I feel like I hear differences, and so I started to think about the fact that it might be possible to predict climate impact just from, a collection of recordings over a relatively short period of time.
Well, wasn't it Bernie Krause who had that revelation about a pond he'd recorded over many years? And
right.
he had that same kind of feeling, like something's changing here. And he even went to the extreme of saying that he was hearing climate change in the acoustic signature of this one place he recorded every year.
Yeah, that's right. And in fact, he put out a little video of like isotope, spectral analysis. And it was at Sugarloaf State Park.
Yeah, right. That's
California.
The same place.
Yeah, and he put out like 4 snapshots on that between 2004 and 2015. And you see like, and I mean, it must be said that during that time there was also selective logging in that area.
Great.
But yeah, I mean, it's devastating. It's an incredible example because in 2004 you have active bird life. The next snapshot you have less. The next snapshot you have hardly any. The next snapshot in 2015 is essentially silent. That's a product of selective logging, but it's also a product of drought and the impact on that natural environment of what's going on.
Well, right now in California, we're going through these incredible fires, which I mean, there have been fires in the past. I grew up in the Redwood area in Northern California. It's not like there weren't fires, but something's changed, man. It's like it's different now. This is like it's something we can come to expect every fall. When the Santa Ana or Diablo winds come through, we're going to have this kind of problem. I mean, we had trouble starting this interview because my electricity has been turned off for 4 days, and I just got it back last night, and my mesh network wasn't working out of my studio, and it took like 5 or 6. That's why I said take 13 at the beginning. It's like anyway.
That's tough. That's tough.
Well, but this thing of sound and data, I mean, it's like I think I really love about what you guys are up to, you and Sabina, with this Acoustic Ecology Lab, is that you're really looking at the world in terms of sound,
right,
and not being so visually locked down,
right,
and finding the kind of detail that we've lost somehow. I mean, I remember hearing about certain indigenous people that could tell like what was going on with the weather and everything just by the color of the river, or by and probably in combination with the sets of sounds of the forest and things that are changing. Because now I'm hearing the rustling of the leaves and the wind, and it's like a different acoustic reality out there.
Yeah, and of course, I mean, indigenous people have extremely highly developed listening skills. And garner a lot of information about the world, the changes in climate, and so on, through listening. And actually, I recently put in a proposal to a funding agency where I said that I thought we should just be running listening workshops across the nation as a really simple way of re-engaging people with the environment they inhabit. Like what's happening now, because listening is also a really unique thing in that it's not in the future and it's not in the past, it's now.
Right,
and
always.
way to be present now in your environment and to learn something about what's around you and what's going on and to reconnect. And it seems to me that, you know, the climate crisis is a product of us being really disconnected with the environments that we inhabit, to the extent that we just either don't know or don't really care anymore because we think they just self-manage or something.
Right.
That our impact is negligible. But if you start just listening, you start to realize, you know, as you're pointing out, that there's lots, that we have massive impact. And
bring on the Amazon drones, right? I mean, what about when the Amazon drones are delivering packages all over a city? You know, it's going to be, whoa, what the hell?
Exactly. In fact, I wrote an article about that for The Conversation a couple of months ago when they first announced that they'd issued several drone delivery licenses here in the US.
Yeah, right.
And the first thing that struck me was that the people who will afford to use those services are the people in the leafy, quiet suburbs, you know, expensive suburbs, and they're living there because they're leafy and quiet, and now they're going to, like, have an army of drones buzzing around delivering them, you know, coffee and muffins for breakfast or whatever.
Well, I mean, and the other part of it is, I mean, you said leafy, it cued leaf blower, which is like the progenitor of this whole like hellish acoustic landscape. You know. Anyway, okay, so.
Yeah, so I agree. And I mean, imagine like most of the Amazon warehouses and so on are in the inner suburban, you know, areas because they want to get things out really fast.
Right.
And if they become like the hub for, I don't know, X thousand drones that are racing, I mean, those areas are just going to be completely unlivable.
For anyone who's taken one of your, you know, listening workshops, for sure.
Yeah, right. Well, for everybody.
Yeah, for everybody, actually. I mean, bars, like I was saying, bars are already insufferable.
Right.
Well, you know, there was one thing that occurred to me that now I'm going to the music space, but this is a relative to sound and data, and that is the sort of overwhelming effect of the overuse of compression and auto-tune on what music actually is. Right. In other words, the music that is drowning out our conversations at bars and restaurants and shopping malls and everywhere is also what they call brick wall compressed. I mean, in other words, it's, you look at the sort of overall pattern of a song and it's just a bar. It's just a straight, flat bar. The quiet parts are as loud as the soft parts, and they're just like sung in a quiet sort of way. Like, I'm still loud, but I'm calling, you know, whatever.
Right.
Yeah.
Right.
And this is like had an effect, I think, on sort of the subtlety and nuance of some of the core expressive qualities of music itself.
Yeah, I guess it also points to the fact that there's increasing competition in the audible domain.
Right.
So the brick wall compression is really to make sure that it's punching through everything else and hitting you in the head all the time.
And so you can hear it in your car over crappy speakers is really what it comes down to.
And over all the traffic and the helicopters flying overhead.
And the drones. Well, you know, that reminds me, though, and I'm not sure if you've heard of this. You probably have because you've, you know, been way into this more than I have. But I read a study a few years ago about a certain beetle that went extinct, and they traced it back to Singapore to, I forget, a flight over this island in Guam, I think, that was the frequency band was the band that species of beetle had evolved. It was its communication band. And so with these flights going over at critical times during the mating season, it disrupted the ecology of the beetle enough to you know, make it die off and become extinct. Have you heard about that at all, or am I?
I haven't heard. Actually, it'd be great if you could send me a reference to that.
Yeah, I think I have it in one early paper from. I read about it like 6 years ago or something. But it's fascinating. When I heard it, I was like, "Wow, that's really like and this is actually, you know, pretty much gets right back to the core part of what you and Sabina are up to with this Acoustic Ecology Lab, of listening to the world, and that the impact that all things have on each other acoustically is what the ecology is, on if you look at it from a certain sort of earball perspective.
Yeah, because if you think about it, so in Joshua Tree National Park, they've had a virus that's been attacking the Joshua trees.
Oh,
so,
God.
so actually, quite a lot of them have died in the last few years.
Yikes.
And for people who know that national park, there's a lot of large rock there, and there isn't a lot of foliage. There's ground cover, but the Joshua trees are probably the main larger tree foliage in that space. And so if you imagine that they die out, then the reverberation time in those spaces is going to increase because there's nothing to absorb the sound.
Right.
Or very little. The frequency content of that sound banging around there is going to change because, again, hard surfaces, are going to reflect the kind of upper mids and so on more.
Right.
And so I've been trying to make the point that it's quite possible that species may die out or leave because they won't be able to talk to each other. They won't be able to hear, when they're being hunted. They won't be able to, track animals that they're trying to, or food that they're looking for, etc. And so I honestly believe that changes in the acoustic properties of environments could lead to, substantial changes in species habitation, and that's actually what you're already pointing out in terms of
right. Well,
accidental link between an aircraft and a particular niche frequency.
Well, and just finding out that there were these sort of, I'd even say Claude Shannon style of channels of information, like that there was a noise source, but the noise source could be divided into bands, and then those bands had specific meaning depending on the biology,
Right.
The things had evolved over millions of years to live in that frequency domain, that for us it's 20 to 20 kilohertz, but for bats it's different,
Yeah, completely different.
Yeah,
it's an interesting point, and actually, because there's a project called the Map of Life, and they've been using satellite photography and all kinds of stuff to map out much more carefully where different species live on the planet. And you can download it. It's free, and it's really cool because wherever I go, I get the Map of Life out and then ask it what's around me, and it gives me a list of species that are living in the area that I'm in.
Oh, wow. And so, do you get into the ornithology, like that whole Cornell lab, bird call space?
Not so much. I love what they do, but we're not looking at identifying species so much at the moment. Because a lot of the previous work in this area, in bioacoustics and so on, has been addressed at counting the species, doing a species count, through sound and so on. Right. And I think what they've missed is listening to the ecosystem. So we've been trying to take a much bigger picture view of what the sound is telling us about the ecosystem as a whole and how that's changing.
That's great.
Back to the Map of Life, because
sure.
I was thinking, as you're pointing out, animals all have a niche area that they communicate in, and so I was actually thinking in the Map of Life project, one could identify the key communication frequency bands, the critical bands for different species, and then make a database of those. And then you could think about designing filters for jet aircraft that would vary based on the environments they were flying over, so that it would try to minimize the energy output in frequency bands that were critical to animals that lived underneath the flight path.
Well, by You mean an aeronautics design in the plane itself, or
No,
something?
like I don't know what it would be, but some kind of big filter that would be put on the jet engine.
Right.
That instead of just getting a broadband burst because it's pushing so much air through there with such pressure,
Yeah.
you would filter that output so that it allowed you to reduce the impact in critical bands associated with animals that were living underneath the flight path. And of course, that would need to be dynamic because that varies, every.
Would depend on whatever
so
bio basin you were flying over. It would change. Yeah.
Exactly.
Well, that's interesting. That makes me think of this thing that was such a weird experience of flying out of John Wayne International Airport in Orange County,
Right.
which is a tragically named airport, and the plane took off and then idled back on its engine speed. And it freaked me out. I mean, it's like, what's going on? Are we going to crash? We're going to die, oh my God. And then once we got out over the Pacific, they punched it, and went up to 32,000 feet. Well, it ends up that the rich people of Orange County had made this, you can build the airport. We want the airport because we want to be able to fly out of our mansions and everything and have a convenient airport. But you can't, blast us with your jet noise over our $6 million whatever, Kardashian estate, and but the thing that occurred to me also was that sound thing. So could be something like that, just back off on the throttle just a little bit. And then, it probably wouldn't have to be very much to change the frequency at the ground level, but I don't know, man. That seems like something that would make a lot of sense if we were like the United Federation of Planets, but not, you know what I mean? How can we get you got to remember who's president. I mean, I can get anything done. I mean, Jesus. Anyway, I won't go there, but yeah.
It's a product of thinking about the broader ecology.
Yeah.
Because I know there's a lot of work goes into designing jet engines that are quieter and quieter.
Yeah, right. So there you could maybe.
Right. But the problem is, one of my kind of pet peeves is that a lot of these things get discussed in terms of, sound pressure level. And so it's like, oh, this sound pressure level's okay, this is not, and so on.
Right.
But as you will well know, you can play a closely oscillating couple of pitches at quite a low amplitude, and it's going to annoy the hell out of people.
Yeah.
Right? So it just shows us.
Yeah, I can make irritating noises. I've been doing it my whole career.
Yeah, but it just shows us that's the psychoacoustics, right? That
right.
Really kind of harsh, rough sound drives us crazy. And that the sound pressure level is only one part of it, and is often really probably the least meaningful part of it. So I don't know, in terms of urban design and as I'm kind of pointing towards, jet engine design, etc.
Yeah, or cars. There was a whole initiative about making electric cars make a kind of sound in traffic that was distinctive, so that pedestrians wouldn't get hit by these quiet new cars.
Yeah,
which is a really interesting problem that hasn't shown up yet, but that's good they're thinking about it anyway.
Right, and Richard Devine just did a whole design for the new electric Jaguar that sounds like it has a combustion engine in it. It's
that's
fully tuned, so you think you've got this big chunky engine under the bonnet.
Oh my God, I don't know about that.
Even though you don't.
Yeah, jeez. I prefer a Dodge Charger, whatever, Mustang.
Like my bicycle.
Yeah, right. Which is a beautiful bicycle, by the way. Anyway,
yes.
What is it? A Bromley, right?
Brompton, yeah.
Brompton, that's it. God.
Yeah.
Yeah, fantastic. Well, okay, we've gone on long enough. I don't want to keep you any longer, but fantastic. I mean, we just scratched the surface as usual. So hopefully, we'll I'll put this on up and we'll keep the conversation going, because this is just a fascinating topic, and I really appreciate you taking the time to talk to me.
Course. Always nice to talk with you, sir.
Yeah, same here, Garth. So, sound and data channel, we'll keep them coming.
Sound and data.